6.5, graphing square roots and cube root functions. So this is the parent function of a square root function. Okay. Why is there only this side of a graph on a square root function?
Because there's already a negative.
Right, I can have negatives plugged in to my x. Okay. So the parent function starts at 0, 0. Okay. If I plug in a 1, I get a 1 out because the square root of 1 is 1. If I plug in a 4, I get a 2 out because the square root of 4 is 2. Now, all along we have talked about when you take the square root of something, you have a positive and a negative answer, yes? Okay, but yesterday we looked at when we plug 4 in, we get positive or negative 2 out, which makes us a parabola into the negative side, okay? When we are doing parent functions of square root functions, we are not putting the negatives in here, okay? Meaning this, my domain is x is greater than or equal to 0, okay? Meaning I can only plug positive numbers in. And my y is greater than or equal to 0, meaning I can only get positive outputs in on the parent function of this graph, okay? A cube root function, can I put negatives into a cube root function? Because I can have a negative cube root, right? I can take the cube root of negative 8 and you get negative 2. Okay? So a cube root function, the parent function, looks like this. This point 0, 0 is my turning point, meaning my graph turns and goes that way and my graph turns and comes this way. Okay? So you're always going to have a turning point on a cube root function. When I plug in 1, the cube root of 1 is 1. Okay? The cube root of negative 1 is negative 1. The cube root of 8 is 2. The cube root of negative 8 is negative 2. Okay? When you are plugging numbers into square root and cube root functions, my suggestion to you is choose numbers you know have a perfect square and a perfect cube. It makes life easier. Okay? Your domain and your range of cube root functions is always, no matter what you are graphing for cube root functions, no matter if things shift or change, your domain and range are always all real numbers. Always. That's just something you memorize. That's easy. You don't have to look at the graph to tell what's happening. It's always all real numbers for domain and range on cube root functions. Now, on square root functions, your domain and range are going to change and vary depending on how we're graphing it and what's shifting and going on. Your domain and range on cube root functions, though, this graph is always continuing that way forever and always continuing this way forever. And if it flips and flops, if it flops because it has a negative here, it continues this way forever, it continues this way forever. Your domain and range are always all real numbers on cube root functions. Okay? Now, we're going to graph two, and we're going to compare them to the parent function, and we're sticking to simple graphs today. Okay? Now, let's talk about this graph. It says graph y equals 1/2 the square root of x. Okay? But it says compare it to the parent function. So the first thing we want to do is put our parent function on this graph. I want both things graphed on the same, which means use two different colors for me. My parent function is very simple. I know that it starts at 0, 0. I know that 1, 1 is an output, and I know that 4, 2 is an output, yes?
Yeah.
So I can just graph it like this. This is my parent function. Okay? Now, let's graph this y equals 1/2 the square root of x. What does that 1/2 tell me is going to happen to my graph? It's going to, it's going to make it so that it shrinks. Okay. So now we're going to plug in numbers. Okay. What are perfect squares? 1, 4, 9, 1, 4, 9. Okay. So let's just plug in 1, 4, and 9 because they're easy. Okay. If I plug in, well, I'm going to plug in 0, 1, 4, and 9. Okay. If I plug in a 0, what do you get out? Okay, so my graph is starting at the same as the parent function. If I plug in a 1, what do I get out? 1/2, because you get 1 times a half, so I get a half. If I plug in 4, what do I get out? I get the 2, and then 2 times a half is 1. If I plug in 9, I get 3 out, and 3 times 1/2 is 3/2, which is 1 and 1/2, right? Okay, so I plug in 1, I get a half out. I plug in 4, 2, 3, 4, I get 1 out. 5, 6, 7, 8, 9, and I get 1.5 out. So do you see this graph in comparison to the other one? Okay, now, I always have to state a domain and range. What's the domain of this function here? What's your domain? What x numbers can you plug in?
Perfect square.
No, I can.
Well, I mean,
What numbers can I not plug into a square root?
no,
Negative. So your domain is that x is what?
greater
Or equal to what?
than
What's to 0? Because it's the first number I can plug in. My range on this. Look at this range. What is my range? Y is what? Where's your graph start at?
0.
So it's greater than or equal to what? 0, because it's not crossing over into here yet. So that's how I figure out my range and my domain.
Okay.
It doesn't cross over here, so my domain starts at x is greater than or equal to 0. So if I look at whatever this starting point is, that tells me my domain and range. Okay?
So since you have the same domain and range, so like should it always not say?
No.
Okay.
Because this point can shift this way, it can shift up and down, it can shift left and right. So you kind of just have to decide, okay? You have to look at wherever this starting point is, and that's going to tell you where the domain and range is. So if this starting point was like down here, my domain would still be x is greater than or equal to 0, but my range would be y is greater than or equal to -4. Does that make sense?
So it just happened to be.
Yeah, it just happened to be the same right now. Now, it still says compare the parent function. So we graph them in comparison. Tell me in relation in words what that means. We've already talked about it. It has to do with this. Graph what's by a half. What does the graph do by a half a unit?
It's smaller.
Yeah, it shrinks. The graph shrinks. Okay? And that's what they want when it says compare to the parent function. I want it graphed compared to the parent function, and I want it in words, and I need the domain and range, and I need an input and output chart. Got it? Okay. Now, we come over to cube root function. So we're going to graph the cube root function. That's pretty simple. Its turning point is 0, 0, 1, 1, 1, 1, 2, 4, 6, 8 is positive 2, right? 4, 6, 8 is -2. So you have a graph that looks something like this. So we sketch the parent function always first. Okay? Now, let's sketch -3, the cube root of x. What do you think is going to happen with that -3 outside of it?
Like
It's going to reflect, and it's going to do what? What's the 3 do?
It goes to the left side.
That's only if something's inside with the x. What did the half do over on the other one?
Oh, it made it smaller.
So what's the 3 going to do over here?
Stretch it.
Stretching. So it's going to flip and it's going to stretch. It's going to reflect and stretch. Now, let's plug some numbers in that we know have perfect cubes. Perfect cubes. 1, 8. Okay, we'll just do those two numbers for now. And then we also have to plug in negatives on this one, if you notice. So we're going to plug in -8, -1, 0, 1, and 8. Does that make sense? Okay. Now, if I plug in -8, what's the cube root of -8? -2. -2 times -3 is
6.
6. If I plug in -1, cube root of -1. -1 times -3. Plug in 0, the cube root of 0. 0 times -3. Plug in 1, the cube root of 1.
1.
And so 1 times -3. Plug in 8, the cube root of 8. 2, and 2 times -3 is... Okay, look at these numbers. Once we get to our turning point, what happens to these numbers down here? Yeah, they're reflecting. They're opposites. They're opposites. They're reflecting. So if I solve this, and then find the turning point, I don't have to plug in the other numbers. I can fill in the chart if I'm using the same ones. Does that make sense? Okay, so I'm going to start by graphing my turning point of 0, 0. I'm going to go to -8, 2, 4, 6, 8, and I'm going to go up to 6. Which is like right here, okay? I'm going to go to -1, and I'm going to go up to 3. I'm going to go to 1 and go down to -3, and I'm going to go to 8 and go down to -6. Now, here's my graph. Okay? Now, domain.
X.
No. What did I say domain and range is always on a cube root function? All real numbers. You shouldn't even have to think. This should just be easy. All real numbers, all real numbers. Always, always, always all real numbers for both. Okay? Now, we compared it, but now we have to compare it in words. So what happened in words to this graph?
It stretches.
Mm-hmm. The graph stretches by 3 units. Well, by 3. I'm just going to put by 3. And flips.
So, since it was negative, would we say we have to say where it stretched to? Since it was -3.
No, you're just telling me it stretches by 3, and then when you tell me it flips, that means that it has a negative with it. That's fine. Just saying it flips. Yes. Okay. The negative is where it flips. That's what it tells me. Okay. So it stretches by 3 units, but it flips because of the negative. Okay, or reflects. You can use either terminology. That's where we're going to stop today. I'm going to give you easy ones like this. Tomorrow we will talk about when things are being added and subtracted to it. Okay.
Wait,